I am told that we are live. Let me know if you see video, hear everything good. Well, all right. Everything is good from the YouTube side. I'm going to go to the LinkedIn side real quick, and then we'll get started. If anybody knows anybody that is actually good at this stuff, that would be awesome. Oops, something went wrong. Copy. All right, let's see if that works. Hold on. All right, we might abandon LinkedIn. I'm going to try one more time. Stream URL. Sorry about this. This is actually really hard to do to keep. Okay. Okay, if this doesn't work, whatever. Forget LinkedIn. You guys are more important. All right, so this is the kit here. This is the finished kit, what we're going to build, but we're not going to talk about that. So just so you know, this is what we're building. And if you're curious why we're building that, it's because, frankly, I don't learn from webinars. I tried. I don't learn from watching people talk. I don't learn from reading a bunch of books, and I don't learn from like virtual machines are good, but when I get my hands on something, that's when I really learn it, which is what attracted me to OT in general, just being able to physically touch stuff with my hands, and that's what we're going to do today. So this is what we're starting with. This is the, let me get back to, this is what we are, this is a 3D printed, the sides here and everything is 3D printed. This little bracket here, that's 3D printed. This fan I mounted already, and I put on this Panduit cover, they call it. So this is a cover that's going to cover all our wires. So that's where we are starting. And the first thing we need to do is start, first thing we need to do is start mounting our equipment. And so maybe I should try LinkedIn one more time. Then we will start mounting, I promise. So, prepare to go live. Okay. Pick a region. Get URL. Copy the stream URL. Copy the key. Yeah, it's not going. Oh well. Too bad, LinkedIn. All right, so let's get to work. The first thing we are going to do is mount all these systems. Mount all these systems on our kit. So this is what you call DIN rail. DIN rail is short for DIN. DIN is like some kind of German standards body, as you can imagine. Before we had this, I don't even know if there was a before we had this, but you used to have to just screw stuff to the back of the panel. And that, of course, is really labor intensive. And when you go to change something, you have to rework everything and screw stuff again. It's just annoying. And this is much easier to manipulate and add stuff. So it has little clips, if you could see. So this is a DIN rail. You can't really see. There we go. So this kind of snaps in on this rail and keeps it in place. So first thing I'm going to do is snap this bad boy in place. Boom. You just snapped your first thing in place. Next thing I'm going to do is, so this is a CPU. This is the brain of the industrial computer. That's going to be the heart of our kit. And this is the most expensive part. This part's like 120 bucks by itself. This is the second most expensive part. And this is the input output card. So this is the card that goes inside. I'm going to put it in there. Goes inside that CPU. And this is what senses your button pushes. And this is what sends outputs. So it energizes things in the field. So like if you think about opening a valve, this is going to open the valve. This is going to sense when somebody pushes a button or when pressure is at it's going to sense pressure or temperature or whatever you have out in the field. And so got to put it the right way around. This just slides in here. And while this is a PLC from Automation Direct and it's not Siemens or Rockwell, Siemens or Rockwell have the same kind of thing. So they have the CPU and then they have input output cards that snap together in not too different fashion. So boom, this is now in. I now have my PLC and my input output card. Now this device here, this little part of the input output card is kind of cool. It is a disconnect terminal block. So if a technician in the field had to replace that input output card, they could snap this off, all their wiring stays with it, put the new one in, snap it in, and they're ready to go. So kind of a cool feature that a lot of these have. The next part of our kit is going to be terminal blocks. So these are terminal blocks. Here, let me show you. I'm actually going to put them all out. So this is a terminal block. It's pretty much a place where you put one wire in the top and then you could have one wire coming out the bottom. And this is where you make connections in the field. So if you have a cabinet, you put all your stuff, wire it up, and then you, at the bottom of the cabinet, there'll be a bunch of these where the wiring goes out to the field, to the motors and valves and temperature sensors and hydraulic systems and all that kind of stuff. It all comes through terminal blocks. So terminal blocks are kind of like the workhorse of the electrical panel. And just like the PLC, the terminal block snaps on this DIN rail. Of course. There, boom. All right. Now, another piece I'm going to start mounting is a circuit breaker. So I added this. I know, Donald, I did not send you one, but I added this recently because I thought it's just a good idea to have some kind of circuit protection in case you cross some wires or maybe leave something kind of exposed that you don't burn your house down. So this is a 5 amp circuit breaker. It also mounts on DIN rail. And this is what you would actually see in a factory control cabinet. So in a control cabinet, you can imagine with wires going out to field devices, let's say in an industrial facility, you want them to be protected in case there's a short or somebody crashes into a cableway, that they don't cause a fire. And that's what these circuit breakers are meant to do. So I put the circuit breaker on there. The circuit breaker is set to 5 amps because that is the current rating of my power supply that I got. And also you want to make sure that the circuit breaker is rated for what the wires are allowed to carry. So that is the main point. A lot of people think circuit breaker is to protect equipment like PLCs, but it's actually meant to protect your wiring. So in your house, you have certain size wiring. You have a circuit breaker that is tied to that size wire. So if something happens and there's a malfunction in a device or a malfunction, or you short something together, it doesn't cause so much heat in that wire that it catches fire and burns your house down. So a lot of places have been burned down by not having the right circuit breaker size for wires, which allows wires to catch fire, and then that's a big problem. So to protect the PLC, it's better to use some kind of fuse. Fuses are, if you get a fast fuse, fuses are really fast. So the second there is a current that goes above a certain limit, it blows that fuse. Versus this circuit breaker is a little more forgiving, because like this fan might go above 5 amps for a little tiny bit and then come back down. You don't want to blow this circuit breaker every time. So we allow it to go above 5 amps every now and then. But if you kept it there for long enough, this would trip. So I'm going to start putting the rest of these on. This is really satisfying, by the way. Yeah, patch panel. Yeah, this is kind of, this is an electrical patch panel if you think about it. Yeah, don't use flammable. Don't catch your house on fire. Uh-oh. What happened? Oh, I don't think anything happened. No, no. All right. I'm going to continue snapping these on. This is really exciting, I know. Imagine if you had like 500 of these. So let me just get a pile of them in my hand here. This is weird. This is doing this kind of backwards is like tying someone else's tie. Very strange feeling. catch up on these. Do larger gauge wires handle more amps? Yes. So if you have, let's say, a 12 gauge wire, I believe, is rated for 20 amps. So you can carry 20 amps through a 12 gauge wire. If you carry more than 20 amps, the size of the wire is not enough to carry all that current without making heat. And once you make heat, that raises the resistance of the wire. It's harder for that electricity to go through. And guess what that turns into? More heat, which turns into more resistance, which turns into more heat, which turns into more resistance, and on until your house catches fire. So, yeah, electrical safety is super key. Hold on. All right, we're making progress slowly. Thank you for that question too. You guys are awesome. Thought I was gonna be talking to myself. And sorry I couldn't get I meant to get Discord working where people can be on talking at the same time, but I'm struggling with this live stream as it is. So we're getting better though. Every day we're getting better. This one was at least started on time for YouTube. So I met a bunch of you last week in Boston talking about. So yeah, more people have seen it than I thought. Kind of cool. And then Mike Holcomb, the celebrity of OT, posted about us. So that's cool. Give yourself one of these. Let's all do that. Sorry, I'm a nerd. All right. Next thing we need is relays. Relays are next. What's a relay? What is a relay? So just unbox the relay. Relay has two parts. This is the body of the relay. This is where the actual, sorry, my family just got over or is getting over the flu. So I am literally dying. I'm dying for you. All right. Ka-chow. So relay has two parts. This is the body of the relay. This is where the electrical connections happen. And this is the ice cube part. That's why they call it an ice cube relay. In here, if you could see, is a coil of wire and a plunger. And when you send electricity through that coil of wire, it turns into an electromagnet and moves the plunger. So, and that switches a switch. So this is a switch that you switch with electricity. So that's why they call it a relay, because you use electricity to switch on other electricity. So if you think about it, the thermostat on the wall of your house is not the thing turning on your huge air conditioning compressor. It's the thermostat on the wall of your house is going to an electrical relay that is then just like this, but bigger, that is pulling in, using the little power to pull in the big power. So that's kind of like what a relay is. And we're gonna wire this thing up and you'll see it. That just snaps on so nice. Look how good our kit is looking already. And what are we can't be 19 minutes into it already? Are we really 19? I gotta speed up. All right, we only need one relay, but two come in the thing, so oh well. All right, so now we have all that working. On the terminal blocks is the convention always PLC and the physical devices at the bottom. At the bottom of the panel, you mean? What do you mean? Yeah, so I would say usually the PLCs go more towards the top or the middle, and then like you have PLC up here, and then you might have networking down. It all depends on how cabinet wiring is pretty subjective, but usually it's not at the bottom because dirt and water and all kinds of stuff ends up at the bottom of these things sometimes. So you definitely want it higher up where it's going to stay clean. It's supposed to be in a clean spot already. Yeah, it's supposed to stay clean. But these terminal blocks will be at the bottom so that when the electricians come through, I was an electrician, so, and they've been crawling all over the plant. They have hydraulic oil all over them or whatever. They're just been working. You don't want them up on the PLC stuff. You want them down on the terminal block wiring up the connections. So, yeah. They might have run, while you have this in a nice clean cabinet, they may have run that cable for, you know, 1,000 feet or 500 feet or who knows where, up and around and through all kinds of stuff to get to whatever field device that is, or to get the power or what have you. Okay, so the next thing we're unpacking is the power supply. So I changed this power supply from when we were at B-Sides just because this new power supply is much safer and safety first. And the other one was kind of big, and you had to wire 120 volt electrical connections, and the value you get from doing that, I guess I don't really think is that valuable compared to all the rest of this, but it is hazardous. Whereas this, you only have that 120 volt connection and much safer. So as far as the rest of this wiring, is 24 volts, and 24 volts is pretty safe, but still it's important to keep electrical safety precautions. So like, make sure you're not sick when you're working, because I don't know if you know this, but if you're sick, the resistance of your body goes down. If you're in the shower, if you are super hot and sweating, all these things make your resistance go down, which means lower voltage can impact you, because it's the current that kills, not the voltage. But the higher the voltage is, the less current, or the higher the voltage is, the more current it can send through your body. So, all right, we got this plugged in. Now this comes with a little connector here, and this is where we're going to wire up our power. So one is plus and one is minus. You can see, barely see it, but this is kind of a cheap one off Amazon, which I like because it doesn't cost a lot of money. But yeah, we're gonna wire it up to this terminal block. Now I'm gonna switch for a second to this. Yes, there we go. This thing here. So we are in this stage. We just mounted everything, and we are going start wiring this thing. And the first part of wiring is installing these jumpers. Now these jumpers are, I will show them to you. They're going to go from the second terminal all the way to the 6th terminal, and then these last 10, I know it cuts off early, these last 10 right here. So let me do back to here. The starting at the second one, we're going to do 5, and then the last 10. So I have these right, cha. So this is, got to open these. Thought I had some that were already open. Oh well. So these are like, I don't know, a few dollars. And what are they? They are a little dangly, probably kind of cool looking. And they screw in and they just tie everything to the same piece of metal, which makes it effectively the same point. And that allows us to do things like have a power rail. So this will be the plus power rail and this will be the minus. And but right now it is way too long at 10. It's 10 wide right now. So I'm going to take 2 of these off. Right here. And these they cut this piece of metal with these wire strippers right here. Ready? This is so satisfying. Hashtag satisfying. My kids would be so proud. Boom. Cut. So then we put our little thingy back in. Oop. Wrong way. There is a wrong way. Don't do it the wrong way. All right. This goes in just like cha. And we're going to screw it in. Ooh, that felt good. I'm going to check the I'm going to check the chat. Oh crap. Do wire cutters come with a kit? That is a really good question. No, they do not. But I can specify. I did specify the wire cutters actually, and got to have a good pair of strippers if you're going to get any work done. So, highly recommend. Yeah, these are pretty good. I got these at Home Depot, commercial electric. I can't remember how much they are, but they do not come with a kit. Should I include them with the kit? That's. But anyway, so that's an interesting discussion. So I do have the kits for sale, but if you are looking for like to save money, it's definitely more affordable to the bill of materials is on the website. I could share that. Actually, let me do that. So if you go over here, the bill of materials is right here, BOM, everything, including the tools. So you can get these wire strippers from Automation Direct. Look like they're 12 bucks. So, but if you buy them, if you want, I also have the complete kit for sale where I package everything up to you and even include like the virtual machines and stuff, so you don't have to build anything yourself. You can just get to tinkering, or it's easier. It's easier, way easier to get started. So all the minutia of going on, going through all this stuff and collecting all the stuff and installing whatever in Ubuntu, all that's taken care of, and you can get to the hands-on fun part. So back to wiring. Let me read. Yes, the kit does have a Weehaw screwdriver. I love these things, so I give them out any chance I get. So if you came to B-sides, I was throwing these out at the crowd. I hit some lady. Sorry, got hit by a screwdriver. So, off by one. Why did I do that? Why did I do that? There we go. This goes like that. All right, we are halfway. Not cool. This might go a little long. Maybe it has an add-on. I like that. Yeah, buying the kit's way easier. But if you're in college, you have tons of time. So I thought. In my mind, everybody has tons of time except me. All right, we got 3 more to go. 3 more of these little tiny jumper screw things. Then we'll have our positive and our negative power rail. All right, next. We are going, guides. We are in this step 2, wiring the PLC, but we want to go to, yes, okay, here we go. So we did that. Next thing we want to do is wire up the power. So we're gonna take the positive on this little connector here. We're gonna take the positive on this one and bring it to the first terminal on the one that is not the power rail, because this is before the circuit breaker. And then we're gonna take the black and take it to the negative one. And then up here, this is gonna connect to the circuit breaker in a minute. So we're getting there, hold on. Let me get my wire out first of all. So wire comes in this box. Here's a red wire, here's your black wire. Unfortunately, use way more red wire than black wire. I don't know. I guess it's just the way I wired up the kit. Maybe make it like so long. Strippers. We're going to cut and we're going to strip. The wire strippers have numbers on them. I don't know if you can see that, but oh, my bad. I had the wrong. Dumbass. All right, so the wire strippers have numbers there. So we are going to strip on, this is 18 gauge. And I chose 18 gauge because this is what you usually find in cabinets. 18 gauge is big enough that it's robust and doesn't deteriorate over time, and can hold a decent amount of current, but at the same time, it's not too big that it's unwieldy and annoying to work with, and yeah, perfect for control wiring inside a cabinet. So you'll see a lot of that. Now this just snaps in here. This is called a, I found out the real name for this is called a cable duct. How fancy. But I've always called it what everybody on the rig called it, or everybody in industry, I should say. In industry, we call this panduit cover. And panduit is, of course, a company name, kind of like, Xerox or Kleenex or something. So it's not technically right. Let me see how I'm going to do this. Yeah, this doesn't work. There we go. So I'm going to put this in like cha. And now this is a craftsmanship thing, right? So electrical work is a craft. When you make that connection, you should not see any of those tiny strands coming out of the terminal block. You shouldn't see exposed wire. It should look nice. It should be insulated. It should be secure. You should be able to pull on the wire and not have it come out. This costs millions and millions of dollars a year, people putting loose wires. You wouldn't think so, but it's true. Loose wires cost a lot of money every year. So I'm going to strip this side now. And I'm going to get my black wire. Where are you, black wire? Right here. Okay. Yeah, so all this is 24 volts DC, except, yeah, it's changed at this block right here, this power block that you can't see right now. Yeah, this power block changes it from 120 on one side to 24 volts, and the rest of it is all 24 volts, which the Navy was saying, when I was in the Navy, anything less than 30 volts was kind of understood to be pretty safe in small current. You can have large current that makes it dangerous, but for small current, less than 30 volts, we always thought was pretty safe to mess with. But still have to be careful. So let me see. I will cut that about there. Now, I guess a note on this wire. This wire is 18 gauge stranded wire. And there are two types of wire. You can have stranded or you can have solid. And of course, there's stranded. You could have different numbers of strands. And what stranded is they take tiny strands of wire, as the name suggests, and put them together into one wire. So that makes, as opposed to solid copper wire, if you've ever played with solid wire, this is really bendable. This can vibrate and it doesn't break. This is better for industrial settings from what I've seen, but it is also more expensive. So this is so much nicer to work with. Like if you're, this is for if you're working on a car or a boat or something that moves, that's vibrates, you don't want to have solid copper wire. Just the worst. I don't know how you land people do it, the solid wire. It's just torture, just torture. All right, that. Now you can't see. There we go. So I am connecting this first negative terminal block. It's tied to this first piece, the first of the metal bus bar connector. So, and I'm putting it in my Panduit cover. And now I have these two hanging out here. I'm going to strip this second one. Where's my little piece? Where's the little piece? Here it is. Oh my God, this is okay. I'm gonna slip these in here. Gotta actually shorten it a little bit. Just the tip. Oh, there we go. So I'm gonna the red goes on the plus sign, like the diagram shows. Oh, and pray to the demo gods today. I did stay up pretty late trying to figure out all this streaming stuff. They make streaming hard. I don't know why they make streaming so hard. Should be pretty easy. My 10-year-old can stream, no problem. All right. One done. This is a delicate part because this thing off Amazon is kind of not the most expensive. I think this is meant for like solar lights or something, this power supply. But it's cheap. I like cheap. So yeah, you could see I connected that there. There's no strands hanging out. That's a big thing that happens. People will have a strand come out and touch the other wire and it'll cause a short and their stuff won't work. And the plant manager will be like, Orin, I don't understand what's going on. This thing won't start up. And then I'll go over and I'll find that little tiny strand and I'll move it and they'll be like, what the hell you do? And I'm just like some kind of crazy hero. So anyway, I don't know if that, yeah, thank you. Thank you. Ground wire is normally solid core copper wire. That is true. But actually, well, in industrial settings, it might not be just because solid copper wire just breaks so easy. Like It's not fair. But all right, so we have our power ready to go when we're ready to hook it up. The next thing we're going to do, I'm going to go over here. Next thing we're going to do is connect this circuit breaker. So you can see the first part goes from where we connected the power to that's not connected, and it's going to go here. And then this is going to power that bus bar thing. So this switch, you're going to turn it on, and that's going to power up this whole bus bar thing. So get the red wire. Let me actually switch to, I got this cool view. Oh yeah, check that out. So now you're seeing, no, that's not the one I want. It's not where I park my car. Okay, so yeah, you can see here we're connecting the circuit breaker to this first terminal, and then it's coming out and going to the second terminal at the bottom. So that is what we're going to do. Okay, so I need, this one is going to go kind of like this over the top and to this. So really short. So I'm going to cut this maybe that long. Strip it. Good stripping in. This is a lot of fun if you like stripping. Wire stripping. Okay, so I'm going to put this in. Oh my gosh. I'm going to put this in right here. And there, it feels tight. Tight. Then you, the next one is going to be right in this top, top of this circuit breaker. So this WeHa thing works in everything, even though this circuit breaker is pretty big screw. If you could see it. Oh man, this is, yeah, the circuit breaker screws are pretty big, but this little tiny screwdriver fits really nicely in there. There's a right tool for the job, so if you get made fun of for using it, I don't know you. Ooh, I misspoke. You need to bring some power into it. This right here is a Klein 10-in-1 screwdriver. It will work you to death. Don't use it. Ooh, she was a tight one. Okay. Central screw is power distribution to the 24-volt session. Yes. So I'll show you in a second. So this is going to go, and there's a little section in there. It goes. You need the big boy for this one. And this, and actually, let me bring this up here. See if it says it on here. It does not. If you see the side of that, if you see the side of that circuit breaker, one side says line and one side says load. And so what that means is those are the two sides of any circuit breaker. When you're looking at a circuit breaker, the circuit breaker makes a connection between two conductors. One of those conductors is called the line side, and that is where the power is. The load side is where your load is. So if you have power coming from the pole, it goes to the line side of our breaker. The rest of your house is on the load side of the breaker. So I connected this top one to the line side of the breaker, And now I'm going to get another piece of red cable and I'm going to wire it to the rest of that 24-volt distribution thing, and that's going to be the load side. So kind of sizing this wire up. Here, I should share what I'm doing. Next time I need to find a better angle. This is crappy. All right, so I'm kind of sizing this, seeing like, okay, I'm going to come out of here and I'm going to go to this first one, right? So I'm going to come out of this circuit breaker, I'm going to go to this first one. So I'd say maybe that long. Doesn't need to be perfect. In fact, you don't want it to be like super tight. So if it's super tight, you're going to only get worse over time. So good to leave. That's what the Panduit cover is there for. The Panduit cover is there to make it look nice, even though it's not perfect. It's like trim in your house. So, okay. So this is the load side. It says load on the side here, and we are going to boom. Yes. And I'm going to put this in there and again, no strands hanging out. Nice, not biting down on the insulation. In school, we got graded on this kind of thing, and even out in the field, your reputation is built off of stupid stuff like that. Like, if you get known as the guy that's a sloppy wirer, you all of a sudden, it happens over the stupidest stuff. Like you accidentally you accidentally screw down on the insulation instead of screwing down on the conductor. And there's no power, of course, that goes to whatever you're sending power to. So then somebody finds it and they're like, well, Oren didn't screw down on the insulation. Like, that's the easiest thing to do. He obviously is not very good at his job, and you'll never live it down. You'll be it'll be your nickname for a long time. So don't do that. So this one's hooked up to the first one. I'm going to hook this up to the second one. Cut maybe right there. I know professional cabinet wires are probably like, this guy is the worst I've ever seen. So I'm sticking that in the hole. Always keep your Weehaw handy. Always tug your wire. Tug it. Got to keep it looking nice too. Which drives me crazy when like the way the wire pulls through will make it lie a certain way. But yeah, see how that looks nice? When somebody pays like, $15 million for a water control system or whatever it is, they want that thing to look nice. So let me see what we're doing. How we're all right, what was the question? Okay, there we go. Yeah, we're up to 15 people. This guy. Okay, so we're getting exciting now. Now we have power on our positive, we have power on our negative, and it's time to wire up power to the PLC. The PLC wiring. Let's see. I'm going to switch to this one, and let's see. We got that done. Now we're going to wire up to the PLC. The PLC goes from the third terminal over to 24 volts and 0 volts to the PLC over here. So, and I have this click plus. It looks like side. So There's one that reads 24 volts and one that reads 0, and then you don't use this PF, and the ground would go on the ground, but I don't have a ground, so we should have ground, but I don't have this kit. But so I'm going to tie to this connector, and this connector just snaps in. So see, this connector just comes out. So I am going to cut a wire. It's going to go from the third one to the PLC, which is about maybe that long. It's taking way longer than I thought, but I'm going long. I don't care. Going past the hour. If anybody wants to hang. All right, so this is going in here maybe. It's kind of like flossing. Did kind of feel like floss. These kind of look like teeth. Okay, whatever, that doesn't have anything to do with anything. Okay, that is in there. This is our first electrical load. Tug that wire, tug it. Tug that wire. And this goes in here. Got a floss that cable. And my black cable. And the black cable let me switch back over here. It is going to black cable is going to the first one in this one. So first one on that bank. I guess the second one, since the first one is the power adapter. So let me switch back to the phone. Got to square off, make it nice and square. We're going to strip with that 18 gauge hole. Boom. You see how easy that is? I picked nice wire for you guys. So you guys have nice, easy. When you actually go to plants, the wire is like somehow some kind of superhuman insulation that is incredibly hard to strip off. Very annoying. Especially like after it's been hardened by various kinds of chemicals over millennia. Okay, that. Got to tug it, tug it. This needs to be a little shorter. So this is where you need to look at the underside of that PLC. It has the wiring labels on there. So I'm going to turn this around here. 24 volts goes on the first connection. 0 volts on the second connection. So Stick that in there. Now this, definitely don't want these, since this is plus and minus together, you want to make sure you don't have insulation sticking out. So that goes like that. And this one. Hand cramp, hand cramp. All right, so this, now I have 24 volts and 0 volts on this. Let me see if I got it right. Looks like I did. Time to floss. Gotta floss. Okay. Now we have our power, like, before it ends. This guy flosses. I do floss. At least every week. No, I'm just kidding. I'm gonna turn this on here. This is the big test. Are we gonna start a fire on live YouTube or not? Start a drum roll. Are we gonna start a live fire on YouTube? Now this is actually a good idea. I'm gonna say, you know what? Let me double check to make sure. So I got my plus here. It goes over to my breaker. I got the black there. Got those in the right spot. Right now, the PLC is the only load, but let's see what happens. I just applied power by plugging this cord in to the power adapter, and we're going to turn it on. We're going to make history by setting a fire on YouTube. Boom. So, and there is the tiniest little power light. If you can't see it, there is a tiny power light. And now we turn it back off. We haven't configured this at all. And the next thing we are going to wire up is we wired that up. We're going to wire these buttons up. And this is, yeah, this is good. So first we're going to wire up these on the top here. That is your digital inputs. So digital inputs to the PLC up here. And that's what these buttons are. You push the button's on. You push let the button go, it's off. Push it, it's on. Let go, it's off. So the top right here, number 1 goes to the terminal block after the power, because you want I'll show you the flow in a second. The flow goes from here through the button, from the power through the button up to the one after the power and in here. And when that power reaches this module, it knows that you pushed that button. And then it goes back. You need a path back to the negative side of the power supply, and that's what this black is. So this black is the path back to the power supply. And if you open up, it seems confusing, but when you look at the, this is what the manuals are good for, reading. You gotta like reading. And this is the way we're gonna wire up this button. So we're gonna come from the plus side. We're using a syncing, it's called syncing way of wiring up a digital input. Goes from plus through the button to the PLC, input sensing, and then back to the minus. And so if you look at the kit, this is coming from the plus side through the button back to the terminal block, through the PLC, and then back over here. So that is what we are going to do, if that makes sense. There's another way to do it that is switching on the negative side. I don't like doing that because then you're sending energized power through the electrical plant and then only switching on the negative side. So I like, in this case, you're switching on the positive and everything after this button is de-energized in a normal state. So then maybe that just doesn't really matter. Either way you pick is good. It's just whether it's going to be a red wire up here or going to be a black wire. So let's go. So first I'm going to get a black wire and I'm going to go from this C. So let me see if I can do this one, and then here we go. So I'm going to go from this C1 on the PLC. Oh, it's backwards. That's weird. Whatever. Things you learn. From the C1 to the negative power distribution rail. So I'm going to take this. I'm going to measure from this thing over to the negative, and it's going to kind of go over the top. Maybe be a little ugly, but people do this in cabinets as well. So if I had a bigger kit, maybe I'd put some Panduit on top, Panduit cover. Okay, so this goes in here. C1, my black one's going to go in C1. This is going to be the common for all the buttons. And if you, I didn't put a lot of instructions on how to wire up the kit, because if you just follow along with this document, it tells you where to put every wire. So wiring up the kit is not super difficult. And this goes to the first one on the top. See that? Professional. And what's the thing we got to do? Tug the wire. Tug it. Tug it. Tug that wire. Okay. Next, we're going to take this red and we're going to go from the blue 1 connection over to the one after the power rail. Actually, maybe we'll go in the path of the power. Think? Let's do that. So I'm going to get out my red button. No. So this is how the button comes. The button comes in 2 pieces. This is the light portion and it has the plunger. And when you push that plunger, it pushes something in the back. I don't know if you can see it, but this is the contact that gets pushed. This is the contact that gets pushed. And this fits, this is a very typical industrial thing right here. This fits in the back here. And they go together. So one part is the kind of the body and the light, and then the other part is the electrical contact for the switch. I don't know why they do it like that, but oh, maybe so you could switch out. So these switches can be different. This switch can be normally open, where it's open and then you push it and it closes. An open switch means nothing's flowing through it. Closed switch means electricity is going through it. So open, closed, on a normally open. This is a stop button. This is normally closed. So right now, there would be electricity flowing through here. If I push it, the electricity stops. That's normally open, normally closed contacts. And that's going to come up all over the place. So that's right, tug it. You got to tug it. So normally open, normally closed, super important. So I'm going to mount this to my kit. Now this just goes like that, comes apart. This fits just like that. And there we go. Maybe I have to loosen up. These they're little screws that tighten it to the mount. So I'm gonna loosen them up a little bit. All right, there we go. And I might as well get my green one out. So my green one, that is my start button. And there's been some debate over whether I probably should have called the green one. Sometimes green means go and sometimes green does not mean go. Kind of crazy. Electrical people are annoying. So yeah, like this circuit breaker, when it's off, it is green, which means it's safe to touch. When it's on, the little flag turns red. So I've heard some people say that I should have made the kit do the same thing, where on means it's red, off means green, safe to mess with it. But ain't nobody got time for that. Too busy hacking. So, but that is a thing, a debate, red versus green, especially in Europe. Europe is really strict on colors because, you know, it's important. People can actually get confused and get killed. So I got my buttons on there now. They just fasten to, they split apart and then they go through that hole and you could put them back together and tighten the back screws on. So, and in the back is the button part. So the connections, the electrical connections go on the button part for the button. And I'll show you the light in a minute. So for the button, I'm going to go from, let me see, from this, what is that? The next one in the power rail, I'm going to go to the red. So I'm going from this fourth one over to get my floss out. Maybe this long? Yeah. And then I'm going to need, no, I don't need, well, I will need 2 of those. So I'm just going to cut the same length again. Because I got to get there and I got to get back. So imagine this is just like any other switch in the world. I'm going to strip it. Floss. Goes in the first one that's not, I need a holster for this screwdriver. Where is it? Oh, here it is. Boom. And this goes in the cable duct and comes to the back end of this thing. So I'm going to make it a little shorter. I'm going to strip it. I'm going to make the connection. So you can't see, I put it on that terminal right there. And there's another terminal just like it on the other side, which I'm going to put this wire. So this wire is going to go on the fourth part of the power rail. This is way more entertaining than tug it. Got to tug it. All right. Let me see. Man. Okay. This is going to go through like this, and it's going to attach to the bottom side. And we will then have ourselves a circuit. And this is actually, you know, I did a lot of electrical work on paper before ever doing it in real life, and the transition from paper to real life is actually kind of weird, because when you're drawing it on paper and you're drawing the schematic and you got the little dots and lines and stuff, they do not line up in the real world the same they do on those papers. And so my first job I went to, I opened a cabinet up and I was like, I know nothing about what I'm looking at, because I'd always studied in school, you know. But in school, the schematics look way different than actual wires running across, making actual real world connections. So we have this button hooked up now. So we have done this part right here, this part. And now we need to do the part where it's going to bring it up to the PLC. So up to the PLC. So that is going to be from this one up to the number 1 terminal. If we zoom in some more, I'm going to go up to the number 1 terminal. So I'm going to take this piece of wire right here and go. We're going from this number 1 terminal to this terminal. So and this is where I get to be a stickler. I like it to look really nice. This top section here. Has to be aesthetic. That fits in nicely like that on the number 1 terminal on your PLC. Tug, it's good. And I like this to fit nicely, so I'm gonna measure it. It is gonna go to this one, so maybe like that. Yeah, if I cut like right here. Okay. Okay, so that is the button. So we have it going from, let me check. Yes, we have it going from the power to the top of the button, out of the bottom of the button, and when you push the button, it makes and breaks that, out of the bottom of the button, and then over to this terminal block where it goes into the PLC as the first input, digital input, and then the power comes back out here to the negative. And that is our circuit. Should we try this thing? What sort of nickname does a Mr. Messy Wires come up with? I don't know. It's good. Mr. Messy Wires. That sounds like my cat. Okay. So should we try this thing? We're going to try this thing and see if our input works. So if it works, first of all, there should be no fire. So no fire. There's lights. And if you look there, you'll see a light on the first input. Let me see if I can. Hold on. See if you could see this light go in and out. Do you see the light? Yeah, there you go. You see that light? So like I said, this is normally closed. So under normal conditions, it's letting electricity through. So that's why you're seeing that light on, because the input is being satisfied. When you press it, the light goes out. Let go, the light is on. Press it, the light goes out. And this is pretty typical for stop buttons, just because they've had in the past issues where out in the field, like let's say this stop button is really far away, it's supposed to be in, in real life, this would be way out in the field. And if somebody, let's say, ran over that that wire with something that cut it, like a backhoe or something, and then one day you decided you wanted to stop whatever that was, and you pushed it, if it wasn't normally closed, if it was normally open, then when you pushed it, it would close the circuit for the button, but somebody had already backhoed it. So even though the button is closed, the backhoe created an open in the cable, so that the motor would never stop. And so that's why they made it normally closed. So if ever anything happens, the motor just stops by default, by like fail safe. So that is that's that. Now we are 18 minutes over, but I'm gonna keep going anyway. So let's see. What do we have? I'm gonna do a light. I'm gonna do one of these lights next. So the stop light. So the stop light, I'm going to wire, let's see. Stop. These are the stop buttons. Start button. Start button is the same, so not a lot to show you there. This is the fan power, so we could do this one. And then this is the light. So let's do the light real quick. So the light comes out of number 2. And it goes to, what is that? One, two, three, four, five, six, the 6th one. So the light goes to the 6th one, and then the negative goes over to the negative. So, but the output is more boring, because you can't turn those on unless you connect to the PLC and make the output come on. So, but you can see how it's wired here. So actually, let's do the relay. Relay is pretty fun. So this is the relay part. So we're going to go from, we're going to connect C2, this number 1. We're going to connect up the coil for the relay, and then we're going to connect up the power for the relay. So let's do, first of all, the one that says fan power. Now there's two parts of this relay. When you look at this relay, let me actually take it off if I can. The relay has two parts. There's the coil connection, the part I was telling you about. You send current through this, it activates the switch. You send current through this, and it activates the switch. Then you have the actual part being switched, and that is one comes in here and one comes out there. So when you send current through these things, it'll let power flow through for whatever that is, like our fan. So, but if you think about this, this could be an enormous ship thruster, or it could be the compressor for your air conditioning, or it could be anything where you want little power to turn on big power. So that is, and it also, this could be 5,000 volts. This could be 24 volts. So it's kind of incredible that 24 volts DC can turn on 5,000 volt loads through a relay. So we're going to wire up this relay now. I'm going to put C2 over to the first one on top. So that is going to give power to our digital outputs. So C2 is going to go to over here. Oh, I have the strand hanging out. You see that? Not cool. Is a relay like a soft start? So a relay is a simpler version of a soft start. What a soft start is when you start an electric motor, there's a huge inrush of current. And that inrush of current can trip breakers. It can cause all kinds of problems. It can lower the life of a motor because you're drawing so much current, so much heat. It could heat up the motor. There's all kinds of problems with starting electric motors. And so a soft start is an electronic way to slowly ramp up that motor without it drawing so much current at first. And it does that kind of like by holding back the electricity. And what a relay does is a relay, you send current through one part, and it activates that electromechanical switch, and then switches on another source of power. But you're right, you would send control power to the soft start to tell the motor to start, and that would cause your motor to start. But you would also have a relay in line that would be part of that control mechanism. So that is very similar. It's in the same arena for sure. But it's more geared towards specifically limiting inrush current, they call it. So you don't want to prematurely make your motors die from excessive inrush current all the time. Like fire pumps on the rigs I was on, they were so big that you could only start them a few times an hour because the inrush current was so large. And once you started them, you had to leave them running because even though they're electricity going through them, the fact that they are running and rotating means their motor fan is working and they can cool back down. Because starting and then all that current, and then you stop the motor and there's no air going across it, all that electricity just soaks in and causes real damage. So I'm going to tug on that wire. So we have C1 now tied there, and I'm going to put 1. I'm going to put 1 to, let me see, 1 is going to get sent to that 6th thing, or 5th. Is that 5th? 1, 2, 3, 4, 5. So 5th thing. So the next one is going to go to the 5th one after the. All right, so making progress. This is going to be the first digital output, which will be the fan relay. So when you tell the fan relay to start, it's going to energize this output and allow and send power to the fan coil, the fan relay coil. So this goes like this, and this is going to go to 1, 2, 3, 4, 5. So right there. Okay. One, 2, 3, 4, 5. All right. Now, next thing, we need to send the red cable through so it's going from this relay over here to that 6th one, so maybe like about that much. This 50 feet of cable gets eaten up pretty quickly. I'm going to strip this part just to stay ahead of the curve. I'm in love with my strippers. All right, so this part is going on here. Now, when you see the relay, you could always tell. Here, let me actually. I've been sharing my wrong screen the whole time, so let me zoom in here. Sorry about that. You see this little symbol here? That is the symbol of a coil, and the plus here and the minus there, that's the coil. That's the coil connection. So that's what we're going to wire to right now. So here, that's right here. These two right here, that's the coil. So I got my, oh, well, that's not good. Stop wire just came out. Obviously didn't tighten it hard enough. And that guy. Okay, I tugged on it, I thought. Obviously didn't tug on it hard enough. Obviously. Where's the wire I just cut? I'm losing my mind here. Okay, here we go. So just floss in there. This goes in here. And this part, see if you cut it too long and there's you have a Panduit cover, you could just stick the rest in there. And then when something happens and somebody needs a little bit extra wire, you're the hero because you didn't make it so tight. Okay. Now I'm going to connect it to the plus side of that relay. Maybe next time I should have like a helmet cam or something. That'd be cool. Ah! Okay. And then this part's the easy part. Where you have red, you must have black. So the electrons need a way to get home. Otherwise, there's no power. So this is going to go like that. Maybe a little less. So this putting on the negative side of the contact of the coil. Get in those teeth, floss. And then where did it say to put the, this relay coil goes over to fifth one over. 1, 2, 3, 4, 5. It's really weird doing it like this. All right, so that is done now. We have our relay connected. Let me see. Yeah, ignition switch. Exactly. Okay, so we have our relay, but we want to test the relay, I think, to make sure that we got it right. And so might have to put some juice to it. What do you think? Well, how would I do that? Well, yeah, I could get a piece of red wire I had before. Where's that red wire I had? Oh, here it is. Take this red wire. I turned the power off. You always got to turn the power off. I'm going to stick, here we go. I'm going to stick that in there. Now I'm going to turn this on. Now this is a little bit of a dangerous move, so maybe you guys don't want to do this. But this cable right here has 24 volts on it, and I could stick it inside the one going to the relay, which is this one, I think. So if I stick this in this hole right here, that'll test that I wired it up correctly. Do you hear that? That's the relay. Oh, and actually, I want to show you. I want to show you. Hold on. So if you could see it, oh, you can't see it because I am not sharing. I keep doing this. This is hard. Okay, there you go. There's the relay. See it? So it's making that connection. Okay, back to work. Okay, so we have our relay working. Now we want to do, what's the next thing we got to do? The fan power. So that's the coil. We connected this part and you saw this green light turn on, and that is going to energize and allow this power to flow through. It's a switch. And if you zoom in, you notice another thing you already know about is normally closed, normally open. So if I put it on the top, when the relay is not energized, it will be open, as in nothing, no power going through. If I put it on this middle terminal right here, NC normally closed, that means that when the relay is not energized, the power is going through, and when you energize the relay, it cuts the power off. So these are two different ways you could wire up a relay. Normally closed, normally open, the contacts on a relay. So this is the relay coil. This is the relay coil connections. And then these, the rest of these screws are these are the contact relays. Sorry, the relay contacts. So when the relay energizes, the normally closed contacts open and normally open contacts close. In de-energized, the normally open contacts are open, normally closed contacts are closed. And then this is common. So this is where the other side of the switch. So always two wires go into a switch. One side is up here, one side is down here. Would be safe to wire up the relays before power to the PLC. Yes, you should definitely wire up relays before. You should always work on this with the power off. The problem is if you are have ADD, which if you're doing this kind of work, you probably do anyway, because you don't, otherwise you just read about it. If you have ADD, you forget to turn the power off. But very good question. That's key. You gotta keep the power off when you're working on it. Especially if you do anything at your house, make sure you keep the power off. If you're doing anything with 120, anything more, keep the power off, please. A little CrowdStrike coffee there. Okay, so we have the fan running. We're going to tie. We are going to now tie the contacts. So we did the relay. I mean the coil. We're going to do the relay contacts now, and we're going to use normally open because normally open means that when you're not sending the power to it, the fan won't. When you energize the output, it energizes the relay and starts the fan. You don't want it the opposite. So that is why we're using normally open. When the relay is de-energized, the switch is off. All right, so red cable. This is so much fun. So I need to go from, where does it say I need to do? Always follow the instructions here. So it says to go from the power rail, the next available one, over to fan power. So over to the relay, normally open contact. That's how you say it professionally. I'm going to go from the 24-volt power connection to my 24-volt relay, normally open contact. Sound like a pro. Pro is short for professional. Okay, I got it in there. And this is going to go over to here. So I need it a little shorter if it's going to keep the same aesthetic look. You got to have it look pretty. If you're going to do it, might as well look good doing it. Some good looking stripping. Good stripping. Weehaw screwdriver coming clutch. This is so nice. This Weehaw is so nice. They do not pay me, but still. Power has a way of reminding you that you forgot to turn it off. Yes, I've been reminded. One time I was in a lifeboat and they had huge batteries and I forgot that I had the disconnect in the wrong position and that big battery sparked and whew, that was a whoopsie. But nobody saw it, so I just like nobody. Okay, so I did that one, and now we're going to do the bottom side of it. The bottom side, number 6. Oh, that goes over to the fan. So that's this this cable right here. One side of this cable goes to the relay, and one side goes to the negative power bus. So I'm going to, I think with this thing we can take these wires out, I think. Yes, we can. That's kind of cool. So you don't have to ruin your ruin this cool plug. Oh, you do still have to ruin the cool plug because we don't have anything to crimp this on. Okay, so we're just going to chop this off right here. I hate doing that. Maybe do a little bit of this action. Split these wires apart. Bring your strippers in. More stripping. So now this, obviously the red is positive, black is negative. So let me see if I can, the red is going to go to this bottom side of this, the bottom side of that power, of that relay, because that is the common, that is where the common side of that normally open relay contact. Not normally open relay, normally open contact. So we're not even showing you that, okay. We are we're gonna put this tiny wire on the normally open relay common, and the black is going to go to the negative bus bar. Whew. Now we have our fan powered up. That's pretty cool. Let's see what we have done. We just did this one. So we did all this, and then we did all this down here, connected our relay coil, and then we connected the normally open contact and connected this power back over here. So now when the fan turns on, you're going to send power to the relay. That's going to close this switch, and power is going to flow from the from here, from the power rail over to the normally open contact, which is now energized. So it's going to go through your fan and back over to the negative. And we could test all that out. Well, we can't really, because we'd have to, oh yeah, we can. We could do the thing where we energize the relay. If we energize the relay, will the fan start? I gotta know. Or will there be a fire? So now I'm going to put this in the, I don't know if you heard that. If you're hearing it, hold on. Oh, sorry. So I am now testing the connection. I'm taking it directly from the power. I screwed this wire in, and I'm going to take it directly to the fan relay connection on the terminal block. And the fan starts. The relay energized and the fan started. So I am simulating the digital output from the PLC. Pretty cool. Turn it back off. Unscrew your little death wire. So we did the fan, we did the buttons. We didn't do the start button, we did the stop button. Now we will do the stop light. How about that? Stop light. So the stop light comes from, these are the two outputs here. So stop light, start light. The stop light, number 2, goes over to one over from the fan relay. So, and then it's going to come down to these sorry about that. So the stop light comes from this number 2. This is the digital outputs. The second digital output, first digital output is this fan motor, number 1. Second digital output is the stop light. So it goes up here and over to the light. And then up to the negative power. So let's do that. Red wire. Let's see what the stream health looks like. Excellent. So red wire, I'm going to go from where am I going from? Oh, the C2, I'm going to go over to the one after the relay. So boom. So like something about that. I'm in love with my strippers. Anybody remember that song? Give it a tug. Nice. Tug, tug, tug. Okay, this is going over, and I'm gonna go right here, so maybe a little shorter, right there. Boom. Seems a little long. You see how it's kind of not fitting in there so nicely. It's a little long for my taste, but whatever. And we're going to take some more red. We're going to go from there over to, so I just hooked up this one. We're going to go from that red one over to, from there over to the red button. I'm working in super speed now. I know you guys probably want to get out of here. And this is going to go in that cable tray, bandwidth cover. And oh, look at that. It is like a glove, maybe like a little bit of a tight glove. That was a little short, but worry not. Maybe I'll, so I'll put this one actually at the bottom. So the lights can be hooked up in any direction. Like it doesn't matter if you hook up the top to the plus and the bottom to the minus. It doesn't care which side is plus and minus. I don't think, at least. That would be hilarious. Yeah, it doesn't care. Okay, so this is getting hooked up to, you okay?
Yeah.
All my kids are home sick. Everybody's sick with the flu. I just got over it, so. The flu is no joke this year. Get vaccinated. All right, I just did one side of the stop button. I mean, sorry, the stop light. So the light on the button, not the button itself. We just did the button already. So then I'm going to take this, and this will go to the the black. I need black to go back to the negative. So taking this black one, we're almost done, guys. The black one is going to go and is going to connect to like the fourth one there. And what the heck is going on here? Okay. So now we have adding lights just don't care. Okay, so we have the light, we have this red light added, and we should test to make sure it works too. So I'm gonna get my little jumper cable out here, the most dangerous part of the project. This is really not optimal electrical testing technique. We'll tug. Okay, so if I send power through this one here, I should turn the light on. So let's see. Oh, and the light turns on. So we got a light, got a fan. Nice. Switch that thing off. We got a button, we got a light, we got a fan, we got a button, we got a circuit breaker. We got digital input, digital output. We wired up the PLC. PLC has power. I think it's pretty successful. 2 minutes to spare of the 2 hours. So thank you guys for for sticking with me. That's been fun. So that is, I guess, unless you guys have any other questions, let's bring up some questions. Let me see if I can see the questions over here. I don't see questions. So what do you guys think? Well, thank you for hanging out with us, and we'll do this again soon. Yeah, thanks. That was real fun. So, but now I hope at least you got a little sense of everything we covered here. We got digital inputs, digital outputs, buttons, what a normally closed, normally open contact is, relay coils, circuit breakers, circuit protection, PLC, how the PLCs get mounted, DIN rails, panduit covers. Oh, we got to do something quick to make our thing look really nice. You snap this back on. Panduit covers, electrical power connections, how to strip wire, how to connect wire, how to spot good craftsmanship. I think we did a lot. So yeah. Yeah, thank you everybody, and I hope this just continues to grow, and hopefully I can not screw up LinkedIn again. But yeah, I'm gonna see how this goes, and until next time, let's call it. Thank you.